that'll tell me how much a plain roll costs. P represents the cost of a plain roll. And it's $10. Woo! Oops. Let's try one more of those. It was so much fun. Catherine and Shauna are selling pies for a school fundraiser. Customers can buy cherry pies or blackberry pies. Catherine sold 1 cherry pie and 8 blackberry pies for a total of $154. Shauna sold 10 cherry pies and 14 blackberry pies for a total of $352. What is the cost of each one of the cherry pie and 1 blackberry pie? A cherry, that says cherry. That looks like crud. A cherry pie costs blank dollars, and a blackberry costs blank dollars. So we don't know the cherry pie cost. I'm going to let C equal cherry pie cost. That's 1 pie. 1 cherry pie cost. And I'm going to let B equal 1 blackberry pie cost. Blackberry pie cost. All right, let's do this. So if we go back up to, whoa, not that. Let's go back to up to Catherine. Oh boy, I'm not going to do what I was trying to do. I learned my lesson. Catherine sold 1 cherry pie and 8 blackberry pies for a total of $154. So 1 times C plus 8 times B would give us a total of 154. Meanwhile, Shauna did some selling. She sold 10 cherry pies. So 10C plus, and then she sold 14 blackberry pies. And she made $352. I'm going to get opposite C's here. So I'm going to multiply the top by -10. This should be entertaining. Although multiplying by tens is pretty easy, actually. So -10 to get a -10C. So I get -10C plus 80B equals 1,540. On the bottom, we get 10C plus 14B equals 352. So now I can add because I have opposite C's, so I can figure out that we have 9. Was that oh boy, I goofed up here. These top 2 should be negatives. Let me highlight that. So we have -10C, -80B, -1,554. So now let me re-add. It gives us -66 blackberry pies. And that gives us, 1,192, 98, 1,188. Let's try 88. So now if I add these 2 together, what do I get? Yeah, that seems right. So 66 blackberry pies would set me back a $1,188. So now let's divide by -66 to figure out how much each blackberry pie is worth. Well, this one's not easy. $20 is too much, but it's $18. Here's why I think this, because 6 times 8 ends in an 8, and 20 is too much. You know what I should have on me is a calculator. Oh, I got a phone in my pocket. I'm going to keep rolling with it because I'm pretty... I'm going to need to do 8 times 18. That's going to be messy. Calculator, what is 1,088? Now, I ignored the negative because I know that a negative divided by a negative is a positive. So I'm doing my calculator 1,188 divided by 66. It was 18. Calculator, for future reference, what's 8 times 18? 144. Alrighty. So now that we know the blackberry pie cost, let's find the cherry pie cost. I'm going to use the top equation because in green those numbers are much smaller. So 1 cherry pie plus, remember Catherine sold 1 cherry pie and she sold 8 blackberry pies. Of course, she got $18 for each blackberry pie. selling a total of $154. Well, she sold the cherry pie. The 8 blackberry pies total out to $144, so that means that C equals 10. The cost of a cherry pie is 10. So now I can write my complete sentence answer. The cherry pie costs $10 and the blackberry pie costs $18. Yahoo! Alrighty. Let's talk about sketching the solution to a system of inequalities. This is going to be similar to numbers 1 and 2 that you did up yonder, except for, folks, if when in slope-intercept form the Pac-Man's eating the y, we need to shade above it. We need to shade where the y values that are greater than the y-intercept. Here, you would shade below. Alrighty, so number 10. Y-intercept for the top equation is -1. We're going, ooh, careful. The slope here is a -4/3. I like to put the negative sign up top, but that's not wrong the way they did it. But now I know that I'm going down 4 and right 3. Down 4, right 3. And then I can reverse it, go up 4, left 3. See how those 3 dots line up? Other big thing. When you have these two symbols, you make a solid line. When you have this symbol or that symbol, you make your line, when you connect the dots, a dashed line. So this one is solid. And then I will shade where y is greater than the y-intercept of -1, so that's up above. And you're not going to shade this belligerently, just make some lines so you know which side of the line we're talking about. Then graph the other equation. The y-intercept here is 2, and the slope is -1/3. So I'm going to put the negative sign up with a 1, going down 1 and right 3. Down 1, right 3. Down 1, right 3. Up 1, left 3. Up 1, left 3. Before I connect the dots, notice that symbol. I'm going to make it a dashed line. So just dashing. Just some little dashes. Oh yeah, dashing through the snow. That was supposed to be an arrow that I just put on there. It was one of the messier arrows of my career. And now we're going to shade below the line. So I'm shading below the line, below the line, below the blue dash line, below the blue dash line. And your solution is where both shadings occur, which is right here. It's this piece of pizza. Pizza. Next one. Y-intercept is 3. Slope is 1, so up 1, right 1, up 1, right 1. I missed on that one. Did you see that blue dot? It was nowhere near where it should be, but good enough. And I started making a solid line, and then I'm like, oh, wait, do I need to dash this line? I don't, so I got lucky. And then let's see. The Pac-Man's facing away from the Y, so I'm going to shade below. Boop, 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 boop. Right here, the other equation, the y-intercept is -3, and the slope is -2, so I'm going down 2, right 1. Kind of a steep line. Notice that inequality sign, folks. And when I connect the dots here, I'm going to dash the line. All right, now which side of this line do I shade? I shade below it. I shade, and if that's tough to see, folks, just realize you're going to shade where the y's are less than the y-intercept. So I'd be down here on this side of the line, and then keep going with it. So where do both shadings happen? This is just the red, this is just the blue, this is neither. This is the solution. Right here. Alrighty, 2 more problems. Substitution. Oops-a-daisy. Naughty Mr. P. We gotta solve an equation for one of the variables, and the best variable to solve for is the one of these 4 that has a 1 in front of it, which would be this y right here. So I'm going to solve this bottom equation for y by adding x to each side. So I get y equals x minus 13. On your test, that step will be taken care of, I believe. So now I have this equation and the bottom equation that I've modified. So now the directions say to solve your system with substitution. So that's where you have to take an expression that equals one of the variables and hug it and plug it in place of that variable. So in the other equation, I'm going to rewrite it, but instead of writing down y, I'm going to write down what y is equal to. Minus 8 times, not y, but times minus times x minus 13. Now I'm going to have to distribute that negative 8 through here. And if you don't think this is a negative 8, it is. Chop slash. Add the opposite. Keep, switch, flip. Careful, negative times a negative gives you a positive 104 there, I think. And then just bring everything else down. So we get negative 16x plus 104 equals negative 24. Subtract. Hey, didn't we just, this will be, never mind. Thought we were going to get negative 144 over there. We don't. We get negative 128. Oh, that'd be 8. So x equals 8. Once we figure out what, because I divided by negative 16 on each side, and then I used a calculator or my brain, but use a calculator on a test, folks, especially, please. Now I can either use, this original equation, or because I trust my math, I could use this modified equation. I mean, I better trust it because I used that equation to get me started here. So y equals, and I like using this one because when you plug it back into slope-intercept form, it's quick math. Watch this. Plug in 8 for x. So y equals negative 5. I'm going to circle that. I'm going to mentally do some work up there. I get negative 64 minus or plus 40, which works. And then in the other one, 5. Oh, negative 8 minus 5 is, yeah, it works. It's negative 13. Remember how we can check our answers if you weren't here on the EL day last week. We did examples 1 and 2 on section 7.1. Get that from someone else then. So if we're doing substitution, we want one variable by itself, isolated. I would solve this top equation for y. So 6x plus y equals negative 22. That means I'm going to subtract 6x to get y by itself. Again, solve for the variable that has a 1 for a coefficient. So now I'm going to hug this. Whoa. And plug this back in for y in the other equation. So here we go, negative 3x plus 3 times y, which is negative 6x minus 22, is going to equal 18. Notice how I copied the entire bottom equation, but I substituted this in for y. So now we distribute. So we get negative 18x and negative 66. So we get negative 21x minus 66 equals 18. Notice this equation from here, folks, has only had x's in it. That means we can actually solve for x, which is a beautiful thing. So we get negative 21x equals 84. So we divide by negative 21. We get x equals negative 4. So then plug negative 4 in for x right up here in the slope-intercept form equation. So we get y equals whatever negative 6 times negative 4 plus 18 is. Oh, where did I get that plus 18 from? Minus 22 is. And when you crunch that out, you get y is 2. So when x is negative 4, y is 2. That's the solution to the system. I'm going to mentally check it really quick, and ooh, it is mentally working out. I am stoked. You know, I don't think I ever wrote the answer to number 12 down in a nice, cute coordinate pair. There we go. Oh, it's so cute. All right, that's your practice test. Realize, think about what the concepts are that you're struggling on. Practice a little more. You can re-practice part of your homework packet. The more practice you can do, the better it's going to go.